For a long time, humanity believed Earth was the ultimate standard for life in the universe. Perfect distance from its star, liquid water on the surface, a protective atmosphere, and a stable climate that allowed life to evolve from simple organisms into complex intelligence. But as astronomy advanced and thousands of planets were discovered beyond our solar system, scientists began to realize something unsettling. Earth may be habitable, but it may not be optimal. Modern science no longer asks only whether a planet can support life. The more advanced question is whether some planets might support life better than Earth. Worlds where life has more time, more stability, and fewer catastrophic interruptions. Worlds that avoid some of Earth's weaknesses while keeping its strengths. Among the thousands of known exoplanets, 3 stand out as some of the strongest candidates for being more life-friendly than our own world. These planets are Kepler 442b, Kepler 62f, and TOI 700d. They are not science fiction concepts. They are real planets detected by space telescopes, analyzed through physics, climate modeling, and stellar evolution. While we have not confirmed life on them, their conditions suggest something extraordinary. Kepler 442b is often considered one of the best superhabitable planet candidates ever discovered. Located about 1,200 light-years away, it orbits a star smaller and cooler than our Sun, known as a K-type star. This detail is critical. K-type stars are more stable than the Sun and can remain active for 20 to 30 billion years, far longer than the Sun's total lifespan. That extended stability gives life far more time to emerge, adapt, and evolve. Kepler 442b is slightly larger than Earth, about 1.3 times its radius. This increased size is an advantage. A larger planet can retain internal heat longer, which helps sustain plate tectonics. Plate tectonics regulate climate by recycling carbon and maintaining long-term temperature balance. They also help support a magnetic field, which shields the atmosphere from harmful stellar radiation. Without a magnetic field, a planet risks losing its atmosphere entirely, as Mars did. The planet receives slightly less energy from its star than Earth receives from the Sun. At first glance, this might suggest a colder world, but climate models show that with a moderately thicker atmosphere, surface temperatures could remain stable and suitable for liquid water. In many simulations, Kepler 442b maintains a calm, temperate climate with fewer extremes than Earth. Fewer extremes mean fewer mass extinctions and a more forgiving environment for life to persist. What makes Kepler 442b especially compelling is the balance of factors. A long-lived star, a stable orbit, a slightly larger mass, and reduced radiation exposure combine to create a world where life could potentially thrive more easily than on Earth. If complex life exists elsewhere in the galaxy, planets like Kepler 442b are strong contenders. Kepler 62f represents a different but equally intriguing possibility. It is also slightly larger than Earth and orbits a cooler, quieter star. What sets this planet apart is its position near the outer edge of its star's habitable zone. While that might seem like a disadvantage, it may actually offer long-term stability that Earth lacks. Planets closer to their stars experience stronger radiation and more volatile climate shifts. Kepler 62f, being farther out, receives gentler energy input. Climate models suggest that if the planet has sufficient greenhouse gases, it could maintain liquid water on its surface for billions of years without extreme temperature swings. Some models even indicate the planet could be dominated by vast oceans, making it a potential water world. Water-rich planets provide powerful advantages for life. Water stabilizes temperature, distributes heat efficiently, and shields organisms from radiation. On Earth, life flourished first in the oceans because water provides protection and consistency. A planet with deeper and more extensive oceans could support life across a larger area and for longer periods without interruption. Kepler 62f's star is also quieter than the Sun, producing fewer energetic flares. This reduces the risk of atmospheric erosion and surface sterilization events. If life emerged on Kepler 62f, it could have enjoyed a more continuous evolutionary path, without the repeated resets caused by asteroid impacts or extreme climate instability. Then there is TOI 700d, a planet that challenges long-standing assumptions about red dwarf stars. Red dwarfs are the most common stars in the galaxy, but they are usually considered hostile to life because of intense stellar flares and radiation. TY-700d is different because its host star is unusually calm. Located only about 100 light-years away, TY-700d is one of the closest potentially habitable exoplanets known. It is roughly Earth-sized and receives nearly the same amount of energy from its star as Earth receives from the Sun. Climate simulations suggest that with a dense atmosphere, heat could be redistributed efficiently across the planet, preventing extreme temperature differences. Despite orbiting a red dwarf, TY-700d's environment may be surprisingly stable. If it has a magnetic field and a thick atmosphere, it could retain liquid water on its surface for long periods. The calm nature of its star significantly improves its habitability compared to most red dwarf systems. What makes TY-700d particularly important is its proximity. Because it is relatively close to Earth, it will be one of the first exoplanets studied in detail by advanced telescopes. Its atmosphere will be analyzed for gases like oxygen, methane, and carbon dioxide imbalances that could indicate biological activity. If life exists on any nearby world, TY-700d is one of the best places to look. Together, these three planets reveal an important truth. Earth may not be the gold standard for habitability. Our planet has experienced multiple mass extinctions, a relatively short stellar lifespan, and a climate system sensitive to disruption. A slightly larger planet orbiting a longer-lived and calmer star, with more water and a thicker atmosphere, could offer life a far more stable home. This does not diminish Earth's importance. Earth is our origin, our reference point, and our only confirmed example of life. But in a universe that is nearly 14 billion years old and filled with hundreds of billions of galaxies, it would be surprising if Earth represented the best possible conditions. The search for life is evolving. Scientists are no longer limited to finding Earth-like planets. They are now looking for planets that may be better than Earth. Worlds where life had more time, more protection, and fewer existential threats. Somewhere out there, life may have emerged earlier, evolved longer, and reached complexity without interruption. And for the first time in human history, we are not just imagining these worlds. We are identifying them, studying them, and preparing to analyze their atmospheres in detail. Earth may be special, but it may not be unique, and it may not be the best. The universe is only beginning to reveal how life-friendly it can truly be.